So here we're going to be expressing area with the proper number of significant figures in centimeters squared. Okay, so this is good because when I analyze, what I'm looking for, my wanted, is area in centimeters squared. Okay, and my given is a length and a width, and it doesn't really matter what I pick, so I'll just do 87.59 centimeters and 35.1 millimeters. Okay, now what I'm gonna notice right away is that the millimeters and the centimeters are not in the same units. Okay, so maybe I need to write out some conversion factors here. Okay, so maybe I don't know how many millimeters there are in a centimeter, but I know how many millimeters there are in a meter. There are 10 to the third millimeters equals 1 meter. And I know how many centimeters there are in a meter. 10 to the second centimeters equals 1 meter. Okay, if you know how many millimeters there are in a meter, by the way, it's 10, you can do that. I'm fine with that. I'm showing you something that you should know, because you should know everything in relationship to the base. Okay, so my plan, well, this is pretty simple. It's area equals length times width. Okay, so now I can plug this in and I can use dimensional analysis right in the problem. Okay, so I want area, and maybe is my length, and solve. Area is my length times my width. Okay, but my width is not, oh, Mr. Ryan, you crazy boy. See, my problem here is I didn't put my units in, and that's bad. Okay, 35.1 millimeters. Now I need to convert this millimeters to centimeters, because centimeters times centimeters would give me centimeters squared. All right, so I can just add right on to the end of this, right? Here's my conversion factor, millimeters to meters, because I know these, and then meters to centimeters. Okay, so now my millimeters cancel out, my meters cancel out, my centimeters times centimeters gives me centimeters squared. Okay, so I'm going to go ahead and plug this into my calculator, and again, it's nice that everything lines up like this in dimensional analysis. So I can do my 87.59 times 35.1 times, oh, delete. And actually, my next step is not multiplication, it's division, divided by E3, and then times E2. Okay, and that gives me 3.0814162 times 10 to the second. So I need to go back and I need to figure out how many significant figures I have. Well, this number has 4, this number has 3, and these are definitions, so they're infinite. So I need to use the least number of significant figures, which means I'm going to use 3 significant figures. So that's going to be 3.08 times 10 to the second. Centimeters squared. Okay, now I can check my order of magnitude. Okay, basically just by saying this is 9 times 10 to the first, and this is, let's say, 4 times 10 to the first. So 9 times 4 is 28, so that's 28 times 10 to the 1, 2. Okay, so that's 28 times 10 to the second, and then, which is 2.8 times 10 to the third. Okay, I might round that at this point to just make it 3 times 10 to the third divided by 10 to the third, so the 10 to the thirds cancel, and then I'm left with 10 multiplied times 10 to the second. Done. Okay, so 10 to the first times 10 to the first, that's 10 to the second. Okay, divided by, or multiplied times 10 to the second, divided by 10 to the third, 10 to the fourth, divided by 10 to the 1. It all works out. Okay, it just depends on how you think about it. But it's important to estimate to make sure that we get close to the right value.